Hello everyone, I'm Paul and today we're solving problem 3446, sort matrix by diagonals. This is a medium one and here I will show you what I think is the most intuitive solution. We are given a grid such as this one and we need to sort each of these diagonals. And here we have the rules. We need to sort the diagonals in the bottom left triangle in non-increasing order. This is the bottom left triangle. Here we are including this diagonal in the middle. And we need to sort the diagonals in the top right triangle in non-decreasing order. And this is the top right triangle. So if we are given this, we return this. For example, let's take the top right triangle, the 3 stays as it is, and we are swapping these two values, 7 and 2. Now here we have 2 in the top left cell and 7 in the bottom right cell. Remember that this diagonal in the middle belongs to the bottom left triangle, so we need to sort this in non-increasing order. And remember, non-increasing basically means descending order, and non-decreasing basically means ascending order. Now we can say this is diagonal 0, this is 1, this is 2, this is diagonal -1, and this is -2. Now if we can get each of these numbers somehow, we can store every element in this grid in the corresponding diagonal. And then we can just sort every diagonal, iterate this grid again, and replace each value in the grid with the corresponding sorted value. Now the main question here is, how can we get the number for each diagonal? Let's say we're here, we know this belongs to diagonal 0, but how can we know this from this cell? Well, here we are at row 1 and column 1. So we can just do column minus row, and 1 minus 1 is 0. So this means here we are in diagonal number 0. Now let's say we are in this cell. We know this should be diagonal number 1. So we are at column 1 and row 2. So we do 1 minus 2 and the result for this is -1. So we know that here we are in diagonal number -1. So let's see the full approach now. Let's say we have an empty map and here we are storing every diagonal as a key. So we have -2, -1, 0, 1, and 2. And the value for each of these keys is an array. And now we are iterating this grid. So first we are here. And we do the current column minus the current row. So we know this is diagonal 0. And we add this value to the corresponding key 0 in our map. So now here we have a 1. Next we are here, we are at column 1, row 0, and if we do 1 minus 0, the result is 1. And this means that this cell belongs to diagonal 1. So we go to our map at 1 and we add the current value. So here we have a 7. And now I think you get the idea, so I will just fill this map. And now we need to sort this. So we can start with the bottom left triangle, meaning this one. And we know that we need to sort every diagonal here in descending order. So what this means in the map is we can take every key that's smaller or equal to 0 and sort each of these arrays in descending order. So after sorting we get this result, and now we can take the top right triangle, meaning this, and we need to sort each element here in ascending order. So we go to our map and we take keys that are greater than 0, meaning these two, and we need to sort each of these arrays in ascending order. So now we can iterate this grid again, and each time we need to get the corresponding diagonal we are standing at. So for example here we are at diagonal number 1. We go to our map at 1 and we have this array. So we just replace every element here with this element. The first element here is 2, so we replace 7 with 2. For example, here we are at diagonal 2 minus 1, meaning 1, so we are here again. And we replace this element with the next element in this array, which is 7, so now this diagonal is complete. And we will repeat the same process for every diagonal, and this is how we can get this result. So this is it for this approach. Now let's go with the code and hopefully you will get the idea. First we say n is the length of grid. Our dictionary is a default dictionary with a default value of an empty list for every key. And now we want to iterate the grid to add to the corresponding diagonal in our dictionary each value. So for I in range n, for j in range n, dictionary at the current diagonal, meaning column minus row, dot append the current cell, grid I, j. And now we need to sort every diagonal, and later we want to be able to pop elements from each array corresponding to each diagonal. So we have two options here. I will show you the first one. First we say for every key in D, if the current key is smaller or equal to 0, this means we are in the bottom left triangle. And here we need to sort diagonals in descending order. So the key dot sort, and we need to use reverse true. Else, meaning if we are in the top right triangle, the key dot sort. And now we can iterate the grid in reverse. We are iterating this in reverse because we want to be able to pop elements from each diagonal. So for I in range n, sorry, this is from n minus 1 to -1 in steps of -1, and for j in range n minus 1, -1, -1. Grid I j is our dictionary at the current diagonal j minus I dot pop. And finally we can return grid. So now let's submit this and see if it works. As you can see, this works and it's very efficient. Time complexity here is big O of n squared plus big O of n squared times log n. Remember, sorting requires n log n, and this is plus big O of n squared. So it's overall big O of n squared times log n. And space complexity will be roughly big O of n squared. And here we are iterating this in reverse because we want to be able to use pop, because this requires big O of 1 time complexity, because we are only removing the last element from an array. And if we want to be able to use pop and we want to avoid this reverse loop, we can remove this, we remove this, and we reverse this, meaning this is now empty, and here we add reverse true. So this is basically the same. Let me submit this just to show you this works. As you can see, this also works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.